We are now going to discuss the first problem related to the parabolic motion. Here it is. Here we have a ball which has an initial velocity 20 meters per second. Then the ball is falling from 100 meters above the ground. Find the horizontal distance reached by the ball when it hits the ground. Okay, so if we have this situation which the initial velocity of the ball only goes to the horizontal direction like this, therefore we can say that the initial velocity in the vertical direction or VOY is 0. And if we want to find the horizontal distance traveled by the ball, or let's say D, we need to find the time needed for the ball to hit the ground. Let's say that's T. Since the initial velocity in the vertical direction or VOY is 0, therefore we have a similar situation like we drop the ball from the same height, 100 meter. So if we drop the ball without an initial speed here, we can say that that's 0, and let's say the ball will hit the ground after T, and you already know that when the ball falls to the ground it will be accelerated by the gravitational G. Therefore the speed of the ball when it hits the ground will be G times T. Now the distance traveled by the ball here will be the final speed G times T, and times the time T divided by 2, or if we put the value G 10 meter per second square, then the distance here will be 5 times T square. So here we also have the same situation which the initial speed in the Y or vertical direction is 0, so that the traveling time of the ball to the ground related to the vertical distance travel can be related by this equation. Therefore 100 meters is equal to 5 times T square, or T square is equal to 20, or the time needed for the ball to hit the ground will be square root of 20 seconds, or it's around 4.47 seconds. So this is the time of the ball to hit the ground. Now to find the horizontal distance traveled by the ball, keep in mind that the ball will go in the horizontal distance with the constant speed 20 meters per second, since we don't have an acceleration in the horizontal direction. So this ball will go to this horizontal direction with the same speed here, 20 meters per second. Therefore the horizontal distance traveled by this ball will be the horizontal speed 20 meters per second times the time to hit the ground, 4.47 seconds. Or here we have 89.4 meters. There is a good simulation related to the previous problem, and you can check on this website, and you can play around with the horizontal speed of the object, so you can compare the horizontal distance traveled by the object when you give the different value of the horizontal speed for the object. So let us now take a look on the second problem. Here we have a ball and it's fired so that it has an initial velocity 100 meters per second with angle alpha, and alpha is 30 degrees. And we are asked to find the maximum horizontal distance when the ball reaches the ground. So this is the maximum horizontal distance. Let's call that the max. And also the maximum height here, or let's call it y max. Now here we have the initial situation where the ball has an initial speed v0 and also angle alpha. We already learned that this ball has the initial velocity in the horizontal direction. That's the first component of v0, or let's call it v0x. This is the initial velocity in the horizontal direction. And also the initial velocity has the component in the vertical direction. Let's call it v or y. So this is the initial velocity in the vertical direction. And you know also the value here is the v0x will be v0 times cosine alpha, since alpha is here, and the value of v0y will be v0 times sine alpha. Here alpha is 30 degree, and by using calculator you can find that the sine alpha will be 1/2 and the cosine alpha will be 1/2 square root of 3. Then you can find the value of v0x. That's the value of v0 here, 100 times 1/2 square root of 3, or we get 50 square root of 3 meter per second. And the initial velocity in the vertical direction will be 100 times 1/2. We get 50 meter per second. So we have an initial condition that the initial velocity here has the first component in the horizontal direction, v0x, and that's 50 square root of 3 meter per second, and also the initial velocity in the vertical direction, v0y, and that's 50 meter per second. This is the the first step we need to find in the typical parabolic problem. So we have to find the initial speed in the horizontal and vertical direction. Now we know that when the ball moves in the parabolic path in at the highest point here, we only have the velocity in horizontal direction. So here the velocity in the horizontal direction, or the velocity in vertical direction is 0. Therefore we can find the time needed to go to the highest point here. And if the ball has an initial velocity in the vertical direction here, 50, so the time to go to the highest point will be 50 divided by the gravity 10. Here we have 5 seconds. So first, the time needed to go to the highest point will be 5 seconds. And then the ball will go to the maximum point here. See, if the vertical position of the initial position and the final position, they are the same, therefore the time needed to go from here to here and to go from here to here will be the same. So this will be 10 seconds, or 5 plus 5 seconds. So now let's calculate the maximum horizontal distance here. Since the ball moves in the horizontal direction with a constant velocity 50 square root of 3 here, so the maximum horizontal distance here will be 50 square root of 3 times 10, or we get 500 square root of 3 meters, or you can calculate the value will be 866.025 meters. Secondly, now we need to find the maximum or the highest point y max. As we already calculate before that the time needed to get the highest point is 5 seconds, and then the initial speed here is 50, therefore the highest point y max here we can calculate that will be 50 times the time here, 5 divided by 2, or we get 125 meters. Now, still using the same problem, we are asked to find the velocity at 3 seconds. Alright, so we already know that the ball will be at the highest point at t is equal to 5 seconds. So 3 seconds here will be before the highest point. So let's say this is t is equal to 3 seconds. If we want to find the velocity at 3 seconds, we need to see that this is the velocity at 3 seconds. So let me draw here. And the velocity at 3 seconds has two components. The first one is in the horizontal direction, Vx, and the second one in the vertical direction, Vy. So to find the value of the velocity v here, we need to find the value of Vx and Vy. Now, you already know that in the horizontal direction or x direction, the ball moves with the constant velocity. Therefore, we still have the same velocity, just like the initial velocity in the horizontal direction, and that's 50 square root of 3 meter per second. So this is 50 square root of 3 meter per second. But now, how do we calculate the speed or the velocity in the vertical direction here? Keep in mind that in the vertical direction we have the gravitational g. Therefore, when the ball moves in upward direction, the vertical speed will decrease by 10 meter per second every second. So if the initial velocity in the vertical direction is 50 meter per second, and after 3 seconds, since every second the speed will decrease by 10, so at 3 seconds the vertical velocity will be 50 minus 10 times 3, or you get 20 meter per second. Alright, now we have the both components in the horizontal and vertical direction. So to find the total speed v here, we need to calculate the resultant of Vy and Vx. And since they are perpendicular each other, and we see that the v here is the hypotenuse, so that the v here will be square root of Vx square plus Vy square, or square root of 50 square root of 3 square plus 20 square, or we get square root of 7900, or 88.88 meter per second. So this is the velocity at 3 seconds. Again, we need to find first the component in the horizontal direction Vx and the component in the vertical direction Vy. So this is also good website related to the previous problem. So you have a parabolic motion, and then you can also evaluate the velocity in every position. The second website that I really recommend you to check is this website, PHCT, and you can play around with the parabolic motion in this website. So this is very nice, and you can just go and check this simulation. So lastly, this is also a very good demonstration done by Professor Walter Lewin from MIT, and you can also see the demonstration. You can just go to this website, MIT Open Course. You go to the physics course and find this video number 4, the motion of projectiles, and just go to this time frame. You can start from 47 minutes 38 seconds, and you can see the physics works in our daily life.